If you're a front-end developer, you definitely know the feeling. A project kicks off, everything's clean, simple, and super fast. But then, over time, it just grows. It becomes this complex beast that's slow to build and, honestly, a real pain to change. Okay, let's dive into this universal challenge and explore a really powerful principle that can help us tame that complexity at every single level of the stack. And it always starts small, doesn't it? As developer Fernando Ralho points out, this whole experience is pretty much a rite of passage for any React developer who's been around the block. We've all been there, right? Adding just one more prop, one more little condition, until we finally look up and realize, oh no, we've created a monster. And this right here is a perfect example of what people call Boolean prop hell. It's a sight we all recognize. Every new feature adds another conditional prop, and what was once a simple, elegant component turns into this tangled mess of logic. It's hard to read, it's brittle, and it's almost impossible to reason about. But here's the thing. This isn't just a component problem. It's actually a symptom of a much, much larger architectural issue. So when the pain of that tangled monolith gets to be too much, teams usually find themselves at a major crossroad. They start searching for a silver bullet, some kind of escape hatch from the complexity they've built up. And that search often leads them to one very popular and, let's be honest, very hyped solution. And that solution is micro front-ends. Now, the idea itself is really intuitive, it's powerful. Just like microservices on the back end, you split your massive front-end app into smaller, independent parts. Each team gets to work in its own little walled garden, totally free from stepping on anyone else's toes. I mean, it sounds like a dream come true, right? Well, that dream of independent, fast-moving teams is super compelling. But as architect Jimmy Brick McCry warns, the reality can be very, very different. Instead of getting that true isolation, you can easily end up with what he calls a distributed monolith, which is basically the same tangled dependencies you had before, just now they're spread out across different services and hidden behind network calls. And that quote just illustrates the core danger so perfectly. A distributed monolith is often way worse than the original. And you might ask why? Because inside a monolith, you can refactor those dependencies in a single commit. But once they're distributed, trying to understand, change, and test that hairball becomes a total nightmare of coordinated deployments and really complex integration tests. So the crucial takeaway is this. Don't reach for a brand new architecture just to solve what is fundamentally a code organization problem. The real work, the hard work, is decoupling your business domains within the monolith first. You've got to create those clear boundaries and well-defined interfaces. Only then should you even consider splitting things up. And hey, this isn't just some abstract theory. Let's take a look at a team that put this exact principle into practice, and they did it at a massive scale. The team over at Hasura was facing a monolithic codebase that was grinding their development to a screeching halt. Just to give you a sense of the scale we're talking about, their open source console was nearly 500,000 lines of code. It was a classic hairball, right? And they had a separate pro version that just imported most of it, creating this really fragile and incredibly slow development environment. But by migrating to what they called a modular monorepo using NX tooling, just look at the impact on their developer experience. The feedback loop for a developer making a change went from a painful 5 minutes all the way down to a lightning-fast 10 seconds. I mean, that's a productivity revolution right there. And it wasn't just the developers who benefited. By modernizing their tooling and their structure, they slashed their production bundle size by 70%. Pages were loading 10 seconds faster for their users. This just goes to show that a well-structured monolith can be incredibly performant. So how did they pull it off? Simple. They did the hard work first. They untangled their dependencies and organized all that code into distinct packages inside a single repository. They basically achieved the goal of micro front-ends, that domain isolation, without having to pay the heavy price of a distributed system. Okay, so now let's see how this exact same principle, decoupling before you distribute, applies all the way down at the level of a single React component. We're zooming from that macro architecture right back down to the micro level. Remember our old friend Boolean prop hell? This is what Fernando Rojo calls the configuration approach. We have one giant monolithic component, let's say a Slack message composer, and we try to control its dozens of different variations using this ever-growing list of props. We're essentially just configuring a single, overly complex machine. But what if, instead, we embraced composition? This is the alternative.
Instead of one big monolith, we have a set of building blocks, a header, an input, a footer, some action buttons, and we build the exact UI we need by simply composing these pieces together with JSX. If you don't need a file drop zone, you just don't render it. No Boolean prop required. It's that simple. And the benefits here are immediate and they're profound. That Boolean prop hell just vanishes. The UI's structure is described plainly, declaratively, right there in your JSX, and crucially, you can add, remove, or change features for one use case without ever touching the code for any other. You've achieved isolation, but at the component level. Now this is the key question, isn't it? If we have all these small, independent UI components, how do they coordinate with each other? How does a save button in the footer know what's in the text input, especially if they are completely separate components? The answer is a classic software design pattern, dependency injection. As Tommy Gershong explains so well, it's a technique where you pass dependencies into a component instead of having that component create or reach out for them itself. And it turns out React's Context API is an incredible built-in tool for doing exactly this. And this right here is the magic behind Rojo's compositional pattern. A parent component, the composer provider, uses React Context to create this sort of service hub for all the state and actions. Then, any child component, no matter how deeply nested it is, can just plug in and consume that logic. This is so powerful because it completely decouples the UI from the state. The input field doesn't need to know or care if the state is managed by uState or some complex global store. It just consumes the dependency it was given. So, whether we're talking about a massive system architecture or just a single UI component, we've seen the exact same pattern emerge again and again. It's one powerful, unifying idea that helps us manage complexity at every single scale. So here it is in a nutshell. First, do the hard work of decoupling your domains, whether that's big features in a monolith or small UI elements in a component. Second, compose your solution from these now independent parts. And third, and this is the big one, realize this isn't just for architecture or just for components. It's a fractal pattern you can apply everywhere. And this principle is becoming even more critical than ever before. Rojo makes this fascinating point. In the age of AI-assisted coding, the structure and clarity of our codebase are paramount. AI tools, they're fantastic at generating code, but they work best when they have a clean, well-structured, and composable system to work within. So I'll just leave you with this one thought. As AI becomes a more integrated co-pilot in our day-to-day development, the human's role starts to shift more towards architecture and design. Taming complexity with principles like composition isn't just about making our own lives easier today. It's really about building codebases that are ready for the future of software development itself.